style. When we were doing this style over the past few days, I was always saying to start where it was easy to work with. Well, when you look at the diagram, you have to identify, is the angle for 69 degrees, is it a base angle or is it the vertex angle? It's a base angle, perfect. So since we know this is a base angle, reason why it's a base angle is because it's opposite the sides that are congruent. That means I can figure out my vertex angle. So I add those two together and we get, what is that? 138. So we take 180, back out the 138, and it gives me 42 degrees for my vertex angle. The vertex angle is part of a right angle, okay? Which means I can get to the other triangle by finding the complement to 42. And you get 48, good. Now this 48 is opposite one of the legs, which means this has to be 48. So that gives me 48 and 48 is, what, 96? And that'll leave me 84 for angle 2. So the process to doing these things is kind of the same thing over and over again. You decide whether or not you have a base angle or a vertex angle. Double it or add them or subtract them and just kind of work your way through the picture. That gives you 12 plus 9x equal to 84. Subtract that out, we get 9x is, was it 72? And x is 8. Which one was it? I think you were next. Which one were you looking for? 26, sure. I'll get you after that one, okay? Same idea. It's just now that our picture is a little bit different. Go. Let's try this again. Is the 75 a base angle or a vertex angle? Base angle, good. So you move to the other angle to be 75. That gives you 150 for the base, which means the vertex angle is 30, which gives you a vertical angle of 30, which happens to be a base angle for this guy. So that means this has to equal 30. Gives you x then equal to, what is it, -6, I believe? Move that stuff around. Yeah. What was yours again now? Was it 17 you said? Oh, excuse me. Okay. So in this case here, they want us to mark the diagram or state the sides that'll help us get hypotenuse leg. As of right now, we have the hypotenuse for both of them because it's marked. It's the side that's always across from the right angle. We've got the two right angles, that's good. So we just have to decide which way we want to go for the excuse me, for the leg part. Now me, I just think of it in terms of, well, I want it to kind of match. So I just start thinking about what would this triangle look like if it's rotated to look like the other one? What would my lettering be? See what I'm saying? So if I pick out that, if I say WY, then I'd have CE. That gives me a hypotenuse line. If I said XY, then I'd have DC. That's what you're looking for. You're looking for that correspondence. And then what's weird is that one of them is flipped. So you kind of have to think in terms of, all right, what would I do to this to make it look like the other one so you can make sure that they match up? Does that make sense? It's just a little weird. I mean, it's nothing too crazy. Yes, sir. Yeah. This one's actually even easier. Because you've got the legs, you just have to figure out the hypotenuse. Which one of those is across from the right angle? X, Y, and SR. Perfect. Boom. Done. Yep. Very good. Hypotenuse leg. Because when you have the hypotenuse, there can only be one hypotenuse. You can have multiple legs. What else we got? Excuse me. Oh. That's also why we would make sure that you guys had all the answers on those so we can refresh them, review them. 706. There's one. Probably. Do you have $1? I just did that. I literally just did that 2 minutes ago. Yeah, I just did that wrong. 5. I thought I did that number. But I saw the picture. Yeah. All right. So this is a good one. Do I need to do anything with the isosceles triangle that's on the top? No. I don't have to worry about the isosceles triangle on the top in this case. It doesn't have any bearing to the problem. I will. I'll do that to figure out the angle inside here. Because when I do that, we get what? 52? So you have 52 here. Well, that means this is opposite. That's 52 and 52. Now, that'll allow me to figure out what angle 2 is. Because angle 2 is a vertex angle. So I take 108, or 180, and I back out the 104. That gives me 96 for angle 2. Okay. And then I set that equal to you didn't have to do anything with that isosceles triangle with the 28 degrees for the vertex angle to get any of those angles at all. All we did is we worked to the other one because we had the right angle right away. It's a little bit less work. Here it's real fast. Add 4, divide by 5, you wind up at 20. Oh, I was doing 200. Why? Oh, hello. Hi. Hello. Good morning. Is that better? Hi. Yeah. Sorry. Hey, but you know what? I sold it. I said, hey, this is what it looks like. No. What do you got? What do you got? Holy crap, I cannot math. This is good morning. For some odd reason, I have completely and totally ruined everything in this problem. I have unmapped everything because I have just apparently can't subtract anymore. Literally just not a good day, apparently. So once again, let's start over. So you said you want to take a look at number 25. Number 25, in this case, we don't need to worry about the isosceles triangle on the top because it has no bearing to get us to number 2. Although number 2 is kind of how I feel like right now after doing all those problems wrong. But remember, there's no in math. So we take 90 back out the 28 and you get 62. Let's try this again. 62 is now 62 is now the two base angles. Take the 180 and back out the 124.
Yeah.
Okay. Thanks. I was worried about that for a second there. I was really. Yeah. Apparently just on this one problem. I haven't screwed anything else up, but they did a really good job of messing this up. So. Did you get 56 then for X on that for this part? Okay. So now, hopefully we can do this the right way. So you add 4. Does that feel a little bit better now that you've seen it the right way instead of the wrong way really badly? Okay. I'm sorry about that. I know it's just all. No, anyway, what any others on this one before we go back into looking at our good old friend Mr. Proof? So with any luck, I won't screw this one up, so cross your fingers. No promises. Our 61 degrees are my base angles. Add those together. Excuse me. We get 122. Back that out. We have 58. Vertex angle of 58 here. Take 90, back out to 58 to get to the other triangle. (32) is now the vertex angle. So we have to take 180 and subtract 32 now. Correct. That gives me 74 for each of the base angles. I hope. So yeah, someone please check the math. You can't tell. Apparently, your teacher's an idiot. So. My teacher's an idiot. Yes. It probably is. Yes, sir. Yes. Yep, because this is my vertex angle, which gives me the 74s here. Yeah, then you'd have to solve for X. What's that? No, all you have to do is, guys. No. What you've got here is that you had to get 74 to be able to do the algebra. So now we know angle 2 has to equal 74, so you set that 8x minus 6 equal to 74. And you work to find X. That's what you're getting at. Okay? All right. So let's look back. If you don't have your progression sheets out, grab them. I'm really not that bad. Not all the time. I have moments. So what I did here, real quick today, What I did here real quick today, this morning, is I just real quickly just put together a whole bunch of proof stuff. And what I wanted to make sure I was able to do with you guys is just have a good couple of examples of remembering how you use the progressions and all that. So if I'm looking at that first one, what's your first given? Got right angles. Good. So, what do you know about right angles? What does your progression sheet say about right angles? Perfect. So, first thing you're going to do, guys, is you write down, you've got your angle ABC and angle DBC are right angles. Okay, there's your given. You have to get used to marking your diagrams. It helps you tremendously. When you know you have right angles, draw in the little squares where they occur. We know that they have to be right there because they just said so. When you mark it with the little square box, then it also means that those two are congruent. So just like the progression sheet says, say they're congruent. Good. And why are they congruent? They are. Okay. You have fully utilized that one given. Which means you go to the next one.
No, he doesn't. He does not know.
I don't. I've been telling her all.
Oh, jeez. So much hostility. All right. Go to the next one. B is a midpoint of AD. Whoa. Okay, you're ahead of me here. Hold on. So when you have a midpoint, what does it do to the segment? Cuts it in half, cuts it into equal segments. So you know, by going to the diagram, AB, BD have to be congruent. Okay? Those first four things directly off of the givens and progression. Those first four things directly off of the givens and your progression sheets. If you mark diagrams correctly, it gets to be pretty simple. Now in this case here, yes sir. What's going to happen next? Reflex. At this point, you guys will notice that you've got a side and an angle. When you're doing your stuff, think about ways that you can prove triangles congruent. And when you're looking at them, you look at the diagrams, what you already have marked. As of right now, you've got a side and an angle consecutive. They're next to each other. So the only possible ones you can get, you could have side, angle, side. You could have angle, side, angle, or you could have angle, angle, side. Well, what's the only other thing that's in this diagram that you could state with certainty? The reflexive, that shared side. So you know that BC has to be congruent to itself, or CB, however you write it. If I go BC, congruent, BC, reflex product. According to your diagram now, do you have two triangles that are congruent? Yeah. we have side angle side. Now here's what I always like to do. Notice how they gave you information about the angles right off the bat. They gave you the letters. They gave you the letters that match. Aren't those two angles in the two different triangles? Reuse those letters. You don't have to think them. You don't have to figure out what letters have to match up with what letters when you put them together in terms of the congruency statement. You can literally reuse ABC triangle ABC is congruent to triangle DBC. Side, angle, side. Once you have triangles that are congruent, what can you say about all of their corresponding parts? Correct, but you can say that they are. So the last part I think said, what was it, A and D? I forgot. Yep. You can then say angle A is congruent to angle D. Oh yeah, that thing. Corresponding parts of congruent triangles are. Yes. What do you mean? Yeah, no, that's usually what happens. What happens a lot of times is that you'll have the proofs that we're looking at. The way I look at it with the proof stuff, it is two of them are on like fill in the blank style, and one of them's completely unknown. Okay, so it's nothing too nutty, it's nothing too crazy. We've got the algebra stuff, and we still have how do you set up to solve, what method would you use, what else do you have to mark in the diagram, little things like that. But it's a pretty fair, straight through thing. Remember when you do the proofs, a lot of them will have prove, two angles are congruent, which means you had to do the triangles first and then take that last step. But it's not that it's crazy. 704. I took two away. I found one to be two of them to be duplicated. Two were duplicated. So I got rid of two of them. So there were two. I didn't get rid of all four of them. Within 4 questions, it repeated, so okay, let's go to the next one. This one has numbers because I didn't want you guys to be overwhelmed with too many of the letters when you have all the parallel stuff. Anytime that you have a proof, and if, that didn't work. If the proof itself is given to you and it has numbers written into it, use the numbers. You don't have to write out all the letters. Okay? It's not a big deal if you wanted to say angle 4 as opposed to angle ABJ. You don't have to. All right? So as you go through one like this, you've got your two sets of parallel lines. When you have your two sets of parallel lines, you got one. When you have the two sets of parallel lines, what you want to do is trace them. Remember that? The Z, very good. So when you have the one that, on your progression sheet, you probably have one that looks like that. You had one that looked like a Z, then you had one that had like the two triangles standing next to each other. All right? So when you have one that looks like the Z, first thing we do is that we know that AB is parallel to JG. And then we would trace it. Yep. When you get the Z like that, that's when you have those alternate interiors. So you would start it out like you would any other. So right after I wrote that out, I traced and drew the Z in there. What two angles play the role of the alternate interior? 4 and 2. And like I was saying, if angles are ever numbered in a proof that you get, just use the numbers. It's okay. You don't have to use the letters. That's why we sometimes will put numbers in there just to help make it cleaner so it's easier to follow. You can't write your own numbers in because that's not standardized. So this is where you write if two parallel lines cut by a transversal, alternate interior angles. Right. Ladies and gentlemen, you have to have all of that info here. Okay? It's on your progression sheet. Build that. Go to the next one. The next progression says BG and AJ are parallel. Retrace. Now I have different angles that are at the alternate interior. They're now angles what and what? 1 and 3. Oh, excuse me. What were you saying? Same reason. Yep. Same reason. When you have the Z, it's the alternate interior. Okay. What's next? Very good. Why? Perfect. So back into here, I forgot to do this as I was saying this stuff out. What reason do we have? Very good. Very good. Yeah, it's fine. All you're doing, as long as you're consistent. So we get angle side angle in this case because the side is in between the two consecutive angles. That's the difference between that and angle, angle, side. Two angles are consecutive, then the side's after. Two angles are consecutive, the side is between. That's the difference between the two. So you can say, if I follow through with my tick marks, if I say A, J, B, because I went with that one first. That has to match out then with G, B, then the J. And then you went. Yeah. As long as your letters, I mean, you said, what was it? A. There's no C, but you need G. Yeah. Here's the thing. Let's say you actually wrote the letter C instead of the letter G. You're right. You're okay. You're okay. That's fine. Another one person came out. I'll show you guys here in a second what they did. Then once you have your triangles, then you know your corresponding parts are. And this is where the question came up second hour. Second hour they asked, they said, all right, we know that angle A is congruent to angle G. And we just did the same thing you just did. So they asked their question was, what happens if you write out CPCTC, but you're writing out a CCPTC, or you flip-flop a letter? Am I going to be really, really mad at you?
Yes, it's taking points off. Zero on the problem. So.
If you write GPTGTC or something, if you do, I mean, honestly, if you have 5 letters and they look like C's and P's, you're probably okay. But if you write definition of congruent, or you write triangle, or you write perpendicular, or bisector, or because Murphy said so, if you want, it's going to be wrong. Oh, write CPCTC because Murphy said so? I suppose if you want. No. Once in a while. Very vocal today. Yes. I'm not used to this. You're talking. Real quick on the next one. This was a giant typo, and I realized that after I gave it. So skip over that one. Go to the one in the back real quick. Take a couple minutes and go for it. I'll explain to you what you can do on that third one here in a minute, but I want you guys to take a couple minutes and do this one first. So, now, just to prove a point, not to say that what you did was incorrect, what you did was completely really, really bad, but I bet you somebody else did it too. When you mark the diagram, BC and CD, not CE. Okay? Common. It's very common. You're used to moving up and down thinking midpoints. In this case, it's not. All right. Go to angle B, angle D. Okay. What do I do next? Vertical angles. Yep. Again, if they're numbered for you, use it. Vertical angles are congruent. Mark it. Why are those two triangles congruent? So I'm saying, why are the triangles congruent? You're telling me because of the line that crosses?
Yeah.
So do you see anywhere in these 5 things the word where the line crosses or the lie-in? Do you see anywhere in these 5 that says where the line crosses? See what I'm saying? You can only use those for the triangles. So your 2 triangles will be by angle, side, angle, but here's the trick. You have to label the letters correctly. Okay? So you've got one of 3 possible ways to write these out. You just have to be consistent. If I say a triangle BCA, then I'd have to say DCE, good. If I rotate the letters around, if I go ABC, I'd have to go EDC. I could say CAB, CED, CBA, or CDE. As long as the lettering is consistent, you're correct. It does not matter. And then obviously your last one would have been angle A is congruent to angle E because of it's not Murphy said so. Right. Now, real fast, go back, look back at that third one. Nope, I did not have it on here. If you look back at the third one, I made a typo when I was writing this out. It's supposed to be parallel, not congruent. Because otherwise you get angle side side and it doesn't work. Okay. I apologize, I was writing this up at like 6 o'clock in the morning and I just missed. I just thought it was forward. You gotta have it, because if you had congruent then parallel, you only get one set of angles, a reflexive and another side, you wind up with the angle side side. It doesn't work. You have to have 2 sets of parallel. There's no ask in that. It doesn't work. It was me not with enough coffee in the morning to get that started out correctly. So now it's the same proof as the first one parallel. It's a Z, the Z proof. You get these 2 guys here, you get these 2 guys here, and you get that, and you go angle side. It shouldn't have worked, because if you did it the other way, you'd have these 2, this, and then AD. It does not work. This is angle, side, side. They have to be consecutive. Angle, side, side. It doesn't work. So that's why it was just a typo. So the other thing I was working with second hour. Tomorrow on the test, after you're done, I'll take your progression sheets, but I also want you guys to do these tonight, and I'll put these up on the calendar here in a second. Excuse me. What I did was, there's a handful of problems that are in the review part of the actual chapter. Guys, enough. There's a couple of problems at the very end in the review part of this. The right page. Here we are. I want you guys to do these. I'll collect these things when you guys walk in for your test. The first 5 through 14. I know it seems like, oh, that's a lot of problems. Okay. There's one congruency statement you have to match up the letters. The second was there's 2 diagrams you have to match up which angles match with what and do a little fast one-step algebra. 25 through 28, then on the next page over, are like those pictures of the triangles where they are trying to figure out how would you prove that they're congruent with what's marked. Would you have to throw like the ones we did yesterday, where you'd have to mark up the extra reflexive side to get side angle side, or is it angle side angle, something like that. On 277, then 2 pages later, 3 through 7, again, it's very similar to that, where you're trying to figure out what are the angles looking like, match them out. Those were the isosceles equilateral ones, like we did for the past 2.5 days. Really simple algebra. And then numbers 13 and 14 are 2 proofs of this style. You know, it's a couple of givens, a progression, reflexive, or it might be a vertical angle, proof via corresponding parts. It's super fast, super easy. I know that you guys will have to just use the textbook, just go through all that. This probably should take more than 10, 12 minutes, honestly, to get through those. And then if I were you, like in terms of how I would prepare for assessment-wise on something like this, if you think about it, you've got at least 20, 30 different proofs that we've done. What I would do to compare against the proofs is just to kind of reread your proofs. But when you're reading your proof, take a blank sheet of paper, you know, and look at how you did on your proof, and as you're reading your proof, write down on your sheet of paper what you think would be the next step while you have your progression sheet next to you, because then you can verify, oh, that's right, I did it right. Because we've done every single proof together. We've gone over every single proof. Okay. So aside from that, be able to draw pictures, label. There's nothing on this thing tomorrow that isn't something you haven't done at least twice. Okay. Don't forget your progression sheet. Don't forget a calculator. Make sure you have your stuff ready to roll. Like I said, I'll collect these things first thing, and we'll go from there. On Thursday, we'll start some mid-segment stuff. It's super easy. It'll take us about 10, 12 minutes to do some very, very simple setups. And then we'll finish it with the algebra on Monday, because it usually takes about, actually works out nice to be able to spend it over the time. We'll go from there. We're going to try our best. Chapter 5 is really short. We should be able to knock it out before Thanksgiving. Okay? Probably another test. No quiz, just one test. All right? So we'll be able to knock that out real quick. Then chapter 6 takes a little bit longer to finish up, and we'll need the extra 2.5 weeks to finish before final stuff. It's crazy we're already butting up against those, trying to figure out how much time we got. Whew. What's that? 6 Mondays. I don't know. Never took an AP class. No. I'm sure they're probably just as difficult as